Hello, I'm Tim Lenton and I'm a Professor of Climate Change and Earth System Science here at the University of Exeter. Now, over the last 10 years I've been researching tipping points that might be all around us. So you might have heard the phrase tipping point at some point in your life. It's certainly become quite a popular buzz phrase recently. And this idea of a tipping point really encapsulates the concept that sometimes a small change can make a big difference to the fate of some system. So let me give you an example of that. So this chair is currently in a stable state. It's upright, but there's another stable state for the chair, of course, which is flat on its back on the ground. Now, I'm not sitting on it, as you can see, in the interest of health and safety, but if I were to force the chair by leaning backwards on it, I'd be heading towards an unstable steady state, which is where the tipping point lies. And as I get towards it, I get to a point where I just need a little bit of an extra perturbation to the chair to change it from falling back to one steady state and going into the other. So there we passed the tipping point, and in this simple example of the chair, the force of gravity took it into the other stable state, lying on its back. Now we understand chairs pretty well, so we can predict where their tipping points are. But in the real world, there's a whole host of complex systems where the tipping points are a little bit harder to spot. So unlike my chair example, the consequences of passing a tipping point don't have to be immediate or obvious. If we think about a system as large or complex as the Earth's climate, it can contain several tipping points where we don't immediately see the consequences of passing them. Like when we trigger the loss of a major ice sheet, which will take many centuries to melt, or we begin to cause an extinction event. But certainly we would like to get some forewarning of these points of no return. We can think of a system as a network of interacting things and their activities that together form a complex whole. Now, systems and their tipping points aren't just found in the natural world, but in the human world as well. In one famous example, only 10% of a population has to hold a particular opinion for it to be able to spread through that population. And this can help explain both the stability of political regimes and sometimes why they change abruptly. So when I talk about forcing a system, that refers to a steady pressure that might drive that system towards a tipping point, like in the animation to my right. Now, another concept is perturbations, and those are the small nudges that are happening to the ball in the system we can see in the animation, and they represent the kind of natural variability that is present for any system. Now, sometimes the forcing has taken the system close enough to the tipping point that just a small nudge, a little perturbation, can take it past that tipping point and into a completely different stable state like we see in the animation. So we'll be thinking about the natural world and whether we've reached any tipping points to irreversible change, especially in the climate system. Now, as a civilization, we've been doing our best to force the climate system through ever accelerating global warming. And what I'd like you to do is reflect on the question of whether we're past the point of no return already,